Hi guys, we're back to talk about El Nino. So let me share my screen and so you can see, and then we can do this together. Okay, so El Nino is a particular phenomenon that you've likely heard of if you've grown up in California. And El Nino is particularly a phenomenon that happens when there's a shift in the temperatures in the southern Pacific Ocean. And so because this is something that happens in the southern part of the Pacific Ocean, the technical term for El Nino is El Nino Southern Oscillation, and you'll often hear it referred to as ENSO. I think it mentions that in your textbook and on other websites. So basically what happens during an El Nino event is that there's a shift in what are the normal conditions. So let's go over the normal conditions first. So the normal conditions that we have in the Pacific Ocean, and in particular in the southern part of the Pacific Ocean, are that the trade winds push water, and they're easterly winds. So they flow from the eastern part of the Pacific Ocean, which is over by South America, and they push the surface water from the eastern part of the Pacific Ocean over towards the western part of the Pacific Ocean, which confusingly is in East Asia and like Southeast Asia and Australia. And so as they do that, they actually kind of bulge up the water. There's literally like a bulge of water that gets pushed over towards Australia, over towards the South Pacific. And that is the warmest water in the Pacific Ocean. So the warmest water gets concentrated over that part of the western part of the Pacific Ocean. So in an El Nino year, what happens is that the strength of the trade winds dies down. And it's not very well understood exactly why that happens, but on a scale of like maybe about every 7 years or so, we have a period of time where the trade winds are just much weaker than normal. And so instead of having this big bulge of warm water being pushed all the way over against Australia and the South Pacific, Southeast Asia, instead, the warm water slumps back towards a more central position in the Pacific, and then some of the warm water ends up slumping or sliding all the way back over towards the coast of South America, where it sits against places like the coast of Peru. And so whether an El Nino event is occurring or not is actually measured based on the temperature patterns across the Pacific Ocean. And so when the El Nino conditions are occurring, that means that the temperatures in places like off the coast of Peru and in those parts of the southern central Pacific Ocean on the eastern part of the Pacific Ocean are warmer than average, and they're warmer relative to the other part of the Pacific Ocean over by Australia and Asia, which is ordinarily the warmer part. So that change in the temperature pattern is what defines whether an El Nino is occurring or not. So this is kind of supposed to be an image showing the temperature, surface water. This is the Americas, North America, Central America, South America. This is supposed to be Australia, same thing. So in a normal condition, we have the warm water concentrated over here in red. And then when the trade winds are weaker, I have this little dotted line here, the warm water slumps back towards the Americas. Here's another view, kind of a bird's eye view. So in a normal condition, the trade winds push the warm water over here into the South Pacific. And then in an El Nino year, the warm water slumps back and sits against the Americas, Central America, and South America instead. Here's another view, a remote sensing view with ocean temperatures. This is a temperature anomaly graph. So areas that are in yellow, orange, and red show warmer than average temperatures, and white showing the warmest, warmer than average temperature in degrees Celsius. So 3 degrees Celsius is shown in white, which is equivalent to about 6 degrees Celsius than average warmer, and then the blues and purples are cooler than average areas. And so you can see this is a normal year over here. This is December 2002. You might not be able to see the date. And then this is 1997. And you can see there's all this warm water that's concentrated over here. And you may not be able to see very well because it's in black and the background's black. But this is the coast of South America. And there's lots of warm water pushing right against South America, or there was in 1997 and into 1998, which was one of the biggest El Nino years we have on record. And that's different than in an average year where you can see it's actually green along the coast of South America. So a difference. Okay, so why do we care? Well, there's a number of different climatic impacts that are created globally as a result of this shift in global temperature resulting from this weakening of the trade winds. So the first thing that happens is that all the warm water slumping back and sitting and putting a cap against the water on the coast of South America and Central America stops the normal upwelling process. So in the last lecture, we talked about Ekman transport and upwelling, but if we don't have transport of water off the coast of South America moving with the trade winds over towards the South Pacific, then that upwelling process stops. And so the first people that really noted this cyclical phenomenon were people that lived in areas in South America and places like what we call today Peru. And they noticed that every once in a while during the winter season, they would have these warm waters. And when that happened, the fish would disappear because the upwelling wasn't happening. And they called this phenomenon El Nino because it came around the same time of year as the little baby Christ boy child who supposedly came around December 25th. And so it has that name to kind of tie it to the season when this phenomenon was occurring. So this phenomenon of all this extra warm water sitting against northern South America and Central America, and then even some of it against kind of the southern parts of North America, cause a higher than average humidity along the southern part of the west coast of the United States. And so where we have warmer water, we have more evaporation, we have more water in the air, which leads to more rain. And so we have really wet weather in places like Southern California and Central California. This doesn't necessarily really, the impact doesn't really make it all the way up to like the very northern parts of Northern California and the Pacific Northwest. It's too far away from the pool of warm water. But in places like Southern California, especially, and Mexico especially, they would have much rainier than average conditions. So this graph on the left-hand side shows precipitation throughout time in California, and all these big years where there's really high amounts of precipitation correspond to El Nino year. So there's one back in the 80s, there's one in the 90s. 1997 that I already mentioned. On the other side of the Pacific Ocean, where the warmer than average water is gone and there's colder than average water, there's less evaporation, there's less humidity than normal. So in places like Australia and Indonesia, they have extreme droughts and they have really bad fire seasons because of all the dry conditions that are associated with El Nino. So it's like a totally different kind of impact than we see in places like California, but it's related to the same climatic shift and the same shift in ocean temperatures. And then finally, the way that this warm water impacts atmospheric circulation actually depresses the rate of Atlantic hurricanes. So during El Nino seasons, that's actually usually a safer time to be living over in places like Florida and the Caribbean because you're less likely than average to get a hurricane. So these are some of the climate impacts that are related to El Nino, and I want to mention all of them because I want to illustrate the fact that this one phenomenon can have such a broad range of different impacts on different areas and such a wide-ranging impact, not only in differences, but in like all the places in the earth that feel the impacts of this phenomenon. So going back again to this flood that I mentioned, or this phenomenon that I mentioned, this big 1997, 1998 El Nino. This was, again, one of the biggest El Nino events we have on record. There was huge problems globally. Places like Indonesia and Australia had major problems. Places like California had major problems. There was $35 billion in damage and 23,000 deaths attributed to the different extreme weather associated with this particular El Nino. There was lots of flooding in California, lots of flooding in Plumas County. If you've ever driven down the Highway 70 canyon towards Chico and Oroville, the river came up over the highway, and there's actually a sign down pretty close to the Butte County, Plumas County line, kind of where the tunnels are, that shows just how high over the highway the water actually flowed during that particular flood. And this is another flood in Sonoma County, which is closer to where I grew up. And so this was like a very memorable event. There's lots of landslides and mudslides and flooding events, power outages, et cetera, associated with this particular climate event. And that's the kind of weather that we would always expect to see from an El Nino in Central California. So while we're on this topic, I just want to mention La Nina. La Nina is essentially exactly the opposite from El Nino. It is when the trade winds are stronger than normal and they push the warmer water in an even more concentrated way over towards Australia and the South Pacific and Southeast Asia. And South America has even colder than warmer temperatures and even more upwelling than normal. So here is the average condition pictures with the different colors representing different temperature waters. Here's Australia, New Guinea, Indonesia, Malaysia. Here's South America, Central America. So you can see kind of in a normal condition, the trade winds are pushing warm water this way. In a La Nina condition, you can see this cold plume extending even farther this direction, showing the exaggerated impact of the trade winds. And then in an El Nino event, you can see that all this warm water has slumped back towards Southern and Central America, or South and Central America. So we have opposite effects. We would have wetter than average conditions in the South Pacific and drier than average conditions in places like Central and Southern California, where we live. So anyway, while we're on the topic of El Nino, I just want to mention that as well. Okay, that's a good stopping point.